So welcome to this class. We will be talking about Markov chains and stochastic processes here. So a stochastic process Xn describes how a random phenomenon evolves, and Xn is said to have the Markov property if the conditional probability of any future event given any past event and the present state is independent of the past event and depends only on the present state. So the conditional probability is independent of the past event and depends only on the present state. A Markov chain is a stochastic model that satisfies the Markov property. Now a transition matrix T is a matrix of probabilities where each element Tij represents the probability of moving from state J to state I. All its elements are non-negative and the sum of each column is 1. So Tij is moving from J to I. The matrix T raised to n contains the probability of transition from one state to another after n repetitions. T raised to n is also a transition matrix. And Sn is T raised to n S0, where S0 is the initial state matrix. Now a transition matrix is said to be regular if some power of T has all positive entries. And the Markov chain represented by T is called a regular Markov chain. Now a steady state vector S is an eigenvector of T associated with eigenvalue 1, Ts equal to S. If the sum of the elements of the steady state vector is not equal to 1, we multiply the eigenvector by 1 by sum of the elements. So let's start a problem. Find the steady state vector for this transition matrix T, which is given as follows. So the steady state vector is given by Ts equal to S. That means T minus lambda I S equal to 0. That means lambda is 1. So I have T minus I S is 0. So substituting, we get 0.85 minus 1, 0.64, 0.15, 0.36 minus 1, S1, S2 is 0. So when you multiply, you get 0.85 S1 minus S1 plus 0.64 S2 is 0, and 0.5 S1 plus 0.36 S2 minus S2 is 0. So simplifying, you get 0.15 S1 equal to 0.64 S2, or S1 is 64 by 15 S2. Now if I take S2 is 1, your transition your matrix becomes 64 by 15 and 1, that is your S1 S2. Sum of the elements 64 by 15 plus is not equal to 1. So we multiply the eigenvector by 1 by sum of the elements. That is 1 plus 64 by 17 is 79 by 15. So we multiply by 15 by 79. So 15 by 79 into this will give you 64 by 79 and 15 by 79. So this is a steady state vector. Let's see one more problem. When tourists visit town A, 72% remain in A the next day. So I have drawn a transition matrix. 72% remain in A, 12% visit town B. I have drawn an arrow to town B, which is 0.12. 16% visit town C. When in town B, 77% remain in B the next day. So town B is 0.77. 10% visit town A. So 10% visit town A, so I have 0.10, and 13% visit town C. To the town C, I have 0.13. When in town C, 65% remain in C the next day. So we can see 0.65 here. 20% visit A and 15% visit B. So your transition matrix T will be, the first column will be the entries to which A go to 0.72, A goes to B is 0.2, and A going to C is 0.16. The second column will be the individual entries of B, that is B going to A is 0.10, B going to B is 0.77, and B going to C is 0.13. Likewise for C, C going to A is 0.2, C going to B is 0.15, and C going to C is 0.65. And all the elements are non-negative, and you can check that sum of each column is 1. Explain the initial state matrix S0 is 0.10, 0.7, 0.2. It means that this day the probability of a tourist being in town A, B and C are 0.1, 0.7 and 0.2 respectively. What does S3 mean? S3 equal to T cubed S0. It calculates the probability of a tourist being in towns A, B, C after 3 days. So that ends this class on linear algebra, Markov chains and transition matrices. Thank you.